Okay, welcome to Molecules and Bonds Introduction. This is part 2. We talk about representations of molecules and bonds, and we're going to focus on covalent bonds mainly. So when we say different representations, we mean that there are different ways to present or draw or show molecules. And let's take an example like methane. One way of drawing them or showing methane is through a particle diagram, and that's where the atoms are all shown as like circles or spheres. Another way of doing it is through what's called a Lewis dot structure, where the bonds are shown as either dots or as lines connecting the atoms. The next way would be through a molecular model, and you can make a model of a molecule by using a model kit. You sort of build the molecule by connecting the atoms through bonds. And the final way is a VSEPR structure. Both the molecular model and VSEPR structure show 3 dimensions. Just that in the VSEPR structure, since you're not actually building it, you're just drawing the model, we use things like these dashed lines or this wedge to sort of represent 3 dimensions. The Lewis dot structure, on the other hand, is not 3-dimensional, sort of a flat 2-dimensional structure. Each representation has its importance for various reasons. So in some cases, it's better to use a Lewis dot structure. In other cases, it's better to use VSEPR. So they are all useful in their own way. Now let's get into other ways that we show bonds and electrons. And again, we're just going to specifically focus on covalent bonds. And remember, that's where the electrons are shared between atoms. Each bond has 2 electrons. So if you look, for example, in this fluorine, you can see that there are 2 electrons here in the bond that connects the 2 fluorine atoms. And you can also see that here. In this representation where there's this line, it may be a little confusing, but it's important to know that a single line represents the 2 electrons. So whenever you see a single line, you know that means that there are 2 electrons in that bond. Now, in addition to having a single line or a single bond, atoms can share more than just those 2 electrons. So single, of course, is 2 electrons, but you can also have what's called a double bond where they share 4 electrons, or a triple bond where they share 6. And I want to give you images of that. So we're starting with our single bond. Again, you can see that there are 2 electrons, 2 dots between the 2 hydrogen atoms. In a double bond, like here shown with the O2 or oxygen molecule, you can see that there are 1, 2, 3, 4 dots or electrons between the 2 oxygen atoms. And we draw the bonds as 2 separate lines. And then, of course, for the triple bond, there are 6 electrons shared between them. So 1, 2, 3, 4, 5, 6. And again, we can show that as 3 lines there. The final thing I want to talk about for bonds and bond representation is polar and nonpolar and polar covalent bonds. And polar essentially means opposite. Polar bonds would have an opposite side, like a positive side and negative side. So similar to the way that a magnet has a north and south pole, or the Earth has a north and south pole, a polar bond would have a positive side and a negative side. So what causes bonds to be polar in the first place? That has to do with the difference in electronegativity of the atoms. And remember, electronegativity measures the ability of an element to attract electrons in a covalent bond. We can sort of show that with these dogs playing tug of war, where these 2 dogs are about the same size, so they have like the same electronegativity, so they would be sharing the stick between them equally. Whereas in this case, the dog on the left is much more electronegative or much more stronger, so it's going to pull the electrons or the rope closer toward it. So what does that look like in atoms or molecules, or in molecules, I should say? So here we have, for example, 2 chlorine atoms. So they have the same electronegativity. They're equally strong. So they're going to share the electron equally. Not one of them is going to pull it more than the other. And as you can see, the electrons are sort of directly in between the 2 atoms. In the case where you have hydrogen, which is much less electronegative than chlorine, it's going to be weaker. And so the chlorine is going to pull the electrons toward it. And so as you can see, especially in this image at the bottom, the electrons are closer towards atom Y, which is more electronegative. And so there you have a negative side where the more electronegative atom is, and a positive side where the less electronegative atom is. They're not exactly positive or negatively charged, just that there are more electrons around atom Y, or chlorine in this case. So it's going to have a slightly negative charge. And that's why we use this symbol here, this lowercase delta. The last example, if you have an extreme case where you have like sodium, which is much less electronegative than chlorine, Chlorine is so much stronger than sodium, it's going to rip the electrons away from it. And that's how we get an ionic bond. So an ionic bond is more like an extreme polar bond where they sort of separate because the more electronegative atom just sort of rips the electrons away. And that can be shown here. And in the case with an ionic bond, the chlorine actually becomes a negative anion, and the sodium becomes a positive cation. So that you actually have a positive and negative species. Where here, this is only slightly negative and slightly positive, but they're still connected together. The electrons are still being shared, and here they are not. So this is sort of important because a lot of the properties in covalent molecules will have to do with whether or not the bonds are polar or nonpolar. So we will be taking a look at polarity and using our understanding of electronegativity to sort of help us figure that out. Also, the way we represent a covalent molecule versus an ionic compound will have to do with the fact that you have a positive and negative part. So their representations will look different. Ionic bonds will look different than covalent bonds. So that's another reason why we mentioned this here. All right, so what I want you to do now is pause and check your understanding. You just looked at the some representations of bonds and molecules, and in Google Classroom you have your check-in number 2. Then you're going to fill out the L column of your KWL. That's it. Have a quality day.